All right, everyone. Today we're going to be going over the physics of movement and then a little bit of how it's going to connect to the heart. So to start off, just to go over the concepts of low pressure versus high pressure and how it relates to space or volume. So if you have, let's say, we have the same amount of molecules or the same amount of blood, you could think of it, in each area here. But you can see that in a high space or higher volume, they're not going to have to crash into each other as much, so it's going to be a lower pressure versus the same amount of stuff packed into a smaller space or smaller volume, they're going to be bumping into each other, so that's creating a high pressure. And then the important thing for us to note is that whenever we have a high pressure and a low pressure system, stuff is always going to move from high to low pressure, okay? So high to low. So that's the golden rule for the physics of movement. So then we can think about if we have our little heart drawing over here. Let's say that we have 50 units of pressure in our aorta. That means that from this left ventricle, at least something greater than 50 units of pressure is going to have to be generated in order to move blood from here to the aorta to the rest of the body. So then another consideration is that blood pressure, so blood pressure in the peripheral vessels. If someone has let's say a very high blood pressure, like their diastolic is 120, then from rest, the heart is gonna have to generate more than 120 millimeters per mercury of pressure in order to pump blood throughout the body. So that's why high blood pressure is a risk. So if someone has that lower, healthier blood pressure, then the heart doesn't have to pump as hard in order to move blood throughout the body. So that is why the physics of movement is important.